Good morning, everyone. My name is Alina Malitz, and I'm here today to moderate RULA's today's webinar on Multishaker SRS and superimposed tests. So how are you? I hope you're having a great morning or afternoon, whatever it is in your time zone. And I hope that you can see the presentation screen and you can hear us well. I think we'll allow maybe a couple of minutes before we start the actual presentation. We'll let some more people join. So within 2 minutes, we will officially begin. So good morning again, and we're back. Let me introduce you our main lecturer. This is software engineer Philip Stumscheis. So he will be the one delivering the main part, the theory, showing you our interface and so on. And I will be helping with your questions and we'll be helping with moderation of this webinar. So before we begin, let us all check that everything is okay with the sound and the picture quality. So could you please type a plus in the questions section or like anything you want there, just to make sure that you can hear us. Okay, so let me introduce you to the webinar tool right there. So you have questions section, and it has this like little arrow next to it, so you can press it and the question line will unfold. This is where you can interact with us. This is where we are expecting you to ask any questions or make any comments. We really appreciate the interactive quality of these webinars, and we really appreciate any feedback that you might have. So all through the webinar, don't hesitate and interrupt with your questions. We'll try to answer as we go. So I hope you can hear us and you can see us well. Should anything happen at any point that you cannot hear us, please also you can use the raise your hand tool or the question box to let us know, and we'll try to fix it as quickly as possible. Now we're about to begin and we'll allow maybe a couple of more minutes, and as more people join, we'll just give you a very brief introduction to RULA technologies. I'm not sure if anyone is completely new to RULA, but just in case, let me introduce our company. We're a manufacturer of vibration control data acquisition and software for these applications, headquartered in Riga, Latvia, broadcasting from there. And the solutions that we implement are mainly in vibration testing and data acquisition, and they are applicable widely in automotive, aerospace, research, and other industries. And on the slide on your screen, you can see the advantages that we offer. So as you get RULA devices, you get free updates for the lifetime of your device. You get very agile support, which are the people of support are also connected now. So if you have any complex questions, use this time and they can answer your questions any moment. We offer flexible warranty policy, installation and training both online and on-site. So we're trying not just to provide you with a tool, but to make sure so that as long as you're using RULA devices, you're completely covered, supported. So yeah, if you have any questions about the company, please also don't hesitate to ask them through. But we'll be moving on to our today's topic. We'll be talking about multi-shaker tests, and in particular, we will not just be covering the basic multi-shaker tests, which will obviously be sign, random, and shock, but we'll be focusing on a more complex multi-shaker types, which are sign and random, and SRS. I think we already had a webinar on multi-shaker sign at least, so it's available online. And of course, we'll also cover some basics, which is universal for all multi-shaker tests. But today we wanted to introduce something which is relatively new to the RULA portfolio, which is more multi-shaker SRS. Okay, then without further ado, I'll be passing the microphone to my colleague and your today's speaker, Philip Stumscheiß. Philip, you're welcome.
Hello everyone. In this webinar we're going to talk about multi-shaker SRS and sign random on random vibration tests. We will also discuss the application, features, and we're hoping to make this webinar interesting and worthwhile. And before we start, let's talk a little bit about our features in multi-shaker tests. We support up to 8 shakers at the same time. We have a frequency range up to 20 kilohertz, and we have a very little phase shift. It is less than 1 degree, and of course we have cross matrix control, which helps you to get the most precision results. Now we will I think we have questions.
Yes, so can you open the previous slide? So you're saying here that the frequency range is up to 20 kilohertz. So generally the frequency range of vibration tests can be like much wider. So is 20 kilohertz is sufficient?
Here we have our maximum frequency range for multi-shaker tests with 2 shakers, but when we're running the test with a lot of shakers and on multiple axes, we need to decrease this frequency range, and in that case you will be able to run the test really quickly and smoothly. And as we know, not many objects need to be tested on high frequencies from, for example, 10 kilohertz up to 20 kilohertz. For example, satellites are tested on frequencies from, for example, 100 hertz up to 1000 hertz. And running multi-shaker tests, we don't need high frequencies. And having little frequency range, we can increase the control speed of our system.
So it is sufficient, in other words, yeah? And how about the minimum phase shift? Why is that important? Why do you highlight it?
It's really important during sign tests, and it's our advantage, and we are proud of it.
Okay.
So now I think we can continue, and I'll tell you some information about the usage and popularity of multi-shaker tests. Firstly, you need to know that Multishaker tests are only an option for testing large objects. For example, you can't place a car or a satellite on single shaker, and in that case, you need to have a large setup from, for example, 4 shakers at one single axis. If we have a car, we place them under each wheel. And in that case, we can perform, for example, real life events replication like road shaking. Also, we can reduce test time because we can influence multiple parts of our testing object, and we can simulate real-time environment, as I mentioned earlier.
Can I ask a question
Yeah.
from me? So you're saying here that multi-shaker tests are so popular, but I don't know, are they actually so popular? Because on me, on management side, I would say it's more like a rarity. So it would be like, I don't know, 1 in 30 cases will be multi-shaker.
They are important and popular in automotive because it is widely used, as I know, in General Motors, because they have a big list of tests for the cars and other devices like electronics. And now it's becoming more popular according to a lot of research in space industry. And now I think we will get more cases in Multishaker in a few years.
Okay, thank you.
And now let's talk about two main parameters for Multishaker tests. And the first one is the averaging number, and it defines the number of measurements which need to be taken for one single FRF calculation. As I mentioned in our previous webinars, all tests which are not based on sign are being controlled by FRF filter calculation. And if you want to get the right control impact from the controller, you need to calculate FRF. And in case of multi-shaker testing, it must be averaged. And here you see a picture, and changing this averaging parameter, you can balance between stability and reaction time of the system. So we have some kind of default value, and if you make it bigger, we will decrease the reaction time but increase stability. On the other hand, we will lower the reaction time, but you will get some kind of a bigger error, but in case of long test, you can wait some time and the stability will also increase. Another parameter is control factor, which is responsible for rigorous selection of the control matrices. By changing this parameter in the software, we can adjust the sensitivity of our control algorithm. So this parameter is used for calculating the influence between the shakers. For example, if we have 3-axis test with 3 shakers, every shaker has its own profile, and by influencing an object, you can influence other shakers. And calculating these control matrices, we try to decrease this influence and make our system more stable. And do we have any questions about our control factor?
Yeah, so is it industry standard to calculate cross matrix control, or is it like a special feature for RULA?
As I know, it's it came from the control theory, and this thing is implemented inside of the controller, and we call this control factor. And I don't know for other companies, but we call it like this, and it works. And
so it's important that if you run Multishaker, you should have it.
You need to have it, and you must have it. And so the higher this parameter, the lower is the sensitivity of the control algorithm. And now I'll enable my camera. And you see our today's setup. We have two regular shakers. We have two control accelerometers on the top. And we have a plate with a car model. I think it represents the multi-shaker usage really good, because on two shakers you can place a motorcycle, some car part, some lawn testing objects, and our first test is multi-shaker sine and random on random test. Let's go to the software and set the profile. Here we open multi-shaker mix tests, and before we start, let's go to configuration, and here let's create a new channel configuration. We press add and call it webinar. As I mentioned, we have two 10 millivolts per G IEP accelerometers. They are placed on the first and the second channel, and we don't need to set the third and the fourth, so we press OK. And after that, on the main tab, we need to create a new test. Here you see our first tab is called tasks, and here we need to create a profile for our test. We press edit here because we have some kind of basic test profile. And here, because we are running a mixed test, we can create three different profile types. We can run it as regular random test. We can add additional random profile over our basic profile. We can add sine signal over our random profile, and we can mix this all together. So here we will run our basic random signal up to 300 Hertz. And here in the bottom, we can recalculate our error mass. Let's calculate it as 1.5 G. We press recalculate. Here we see that our amplitudes changed. After that, we go to random on random. We allow this. And here we have multiple options. We can add a fixed random over this profile, and we can add moving random band across this profile. Let's select start and start, and here we enter the width of our random signal. For example, it will be 20 Hertz, and we will run it from 150 to 200 Hertz, and it will have this amplitude. After that, we go to sine on random. We also allow it, and we will add a fixed sine signal to our profile. Our frequency will be, for example, 220 Hertz, and we will influence our object with 2G amplitude. After that, we apply it, and here you see our profile picture. Here you see our basic random signal, and another random will be moving from left to right, like here, like this. And across this profile, we will have a fixed sine signal, which is marked with this point.
Is the profile the same for both shakers?
Now we will run the same profile, but you can create multiple different profiles and use it for every shaker. But in this case, you need to enter it. I'll show you. Press OK here. And here the next tab is called control loops. And here we select our control channel, the profile we want to generate, our output for the system, and our shaker. We can add multiple axes like here. For example, if we influence our object from different sides and different axes, we can add them, or add them names and specify control loops for them. Now I will delete them. Here you see that our shakers are selected by default, and we have these control loops because we have two shakers. After that, we go to schedule, and here we have one main command. It's called run, but we can add pauses, create reports, save the data, create cycles. But today we will only run our profile for 1 minute. And the next tab is called control. Here we have all main parameters here. Some of them are common with regular mixed test. We have a video in YouTube, so you can watch it. If you have any questions, or write us an email. And here we have our control factor, as shown here. There is small information about its parameters, its values for some kind of shakers. And here we need to have a number of averaging. It's system's response time. For basic multi-shaker system of 2 shakers, I recommend to have the basic values. Also, if you don't want to see all the settings, you can show only main. After that, we go to limits tab. Here we can enter the control values and abort intolerance lines for our profile. After that, we go to channels and select our webinar configuration. After that, we disable the 3rd and the 4th channel. So, and we have a question about notching. Let's go back to limits tab, and here we have notching limits. You can enter them like this, and I described the notching parameters and limits in the previous webinars.
Yeah, the bottom line, it is available for multi-shaker, sign and random on random, right? Mm-hmm.
Now let's apply the settings. And now I need to increase the level on the amplifiers. Today we're using our regular RULA 200 amplifiers as always. And now we can start the test. Here we see that we're generating the signal and we are starting up. The default graph for this test is spectrum. So let's put the scale. And also I see a question about the phase shift graph. Here we can open a phase difference versus frequency graph. Here you see it. Here we're increasing the values, And now we're running the test. And here you see that our random on random profile is moving to the right side and our sign is fixed. Using such tests, you can simulate road shaking because it allows you to do more features and research than regular random tests. And here you see that we're going backwards because we finished our run with this width. So the test is finished, and now we can go to our next topic. It is called Multishaker SRS test. And now, before we start with vibration test, let me tell you some information about the shock response spectrum, or it is also known as SRS. It is used to characterize the frequency response of the shock environments to estimate the maximum dynamic response of structures. It is used to characterize and imitate such events like earthquakes, pyroshocks, and underwater explosions. It is widely used for transient event description, damage potential estimation, and of course in structural design and research. For example, it is used in building spheres, in for example, ship design and research. In that case, you can imitate waves, explosions, and so on. And here you see the main graph in SRS theory that shows that our main principle is based on the representation of time domain data in the frequency domain, and SRS models waveforms response using a set of theoretical single degree of freedom spring oscillators as shown here, and each of them have their own natural frequency. So the horizontal axis of the plot represents the natural frequency of each single degree of freedom, and the theoretical response of each spring is plotted on the vertical axis. And here you need to know that SRS is only a theoretical representation of this response. And now we go back to our software. And here we select Multishaker SRS test. Let's create a new one. Here we need to add a profile. Let's call it test. Here our end frequency will be 500 Hertz. And our amplitude will be 1.5 G. After that, we go to SRS parameters. Here you see the analysis parameters tab, the synthesis parameters, and to get our profile, we need to press this synthesize button. Here you see our resultant signal, and after that, we go to wavelets. They are calculated according to this signal, and you can change them manually and press recalculate spectrum.
Is the profile also going to be the same for each?
Now we're going to have the same profile. I think one day we will make an additional webinar with 3-axis multi-shaker tests, and I'll show you the usage of different profiles on the axis.
Would be interesting. Yeah.
After that, we apply the settings and then go to the control loops. Here we select the profile for the shakers, and as for the question, we can create some kind of another default profile. I'll show you an example. And here you can select different profiles.
Mm-hmm.
After that, in schedule, we enter 100 shocks. We can also invert them and perform them in manual mode. After that, we go to control. Here you see all common control parameters. Here we can enable filtering and also show on the main settings. Here we have our number of averaging and the control factor. After that, in limits, we have our control limits, abort intolerance, and of course we have notching limits. After that, we go to channels and select our webinar configuration and disable the third and the fourth channel. Let's apply the settings and press OK. And now let's start the test, but let me check the configuration of the channels. Here, let's apply it. That's correct. And I press the start button. Here you see our task line. We need to wait some time for the startup. In this test, it may take a bit longer to calculate on all the filters during the startup, but here you see that we are increasing the level. And let's try again. Let's make the startup a bit faster. We will set startup end level to 80% and start the test. In that case, we will make less accurate calculations, but the startup will take less time. Here you see that now we're performing the shocks. And let's go to manual mode. Like in average shock test, we can switch to manual mode and press the shock button to perform shocks. Now let's disable the manual mode, and the test is now continuing in automatic mode. So this test is new to our software, and now in the the release version of 58 and 60 will have this test.
So is it already available?
Yes, it's available. Now I think we can stop the test and switch back to our presentation. And here you see the basic picture of the setup for single access multi-shaker test. So we have our PC connected to our controller. It has two output channels which go to amplifiers. Every amplifier is connected with the shaker, and we need to have at least two control channels for these shakers. So it's the most common and basic setup as we have today. So I think today we discussed our two most interesting multi-shaker tests, which are sign random and random sign and random on random test and SRS. We discussed RULA abilities in multi-shaker testing. So we have an ability to control up to 8 shakers. We have high accuracy. We have minimum phase shift. We discussed the features, and I showed you the ways you can enter the profile for sign and random on random.
Oh, okay. Can you say what test types, like how many are on the RULA portfolio for Multishaker now?
Let's open the software. And here we have Multishaker sign, Multishaker field data replication, Multishaker random, shock, mixed, and SRS. So now we have 6 Multishaker test types.
Anything on the plan to implement?
There are some plans, but I think it will appear not in the nearest future, maybe in 1 or 2 years, we will try to implement a multi-shaker TTH test.
So
but
now
it's
mostly
only in the plans.
Now mostly improvement of the existing ones. Okay. How about, there is a question about reports. So is the report standard for multi-shaker tests, or is it like somehow different, particular?
Here we have our standard report settings here. You can select the graphs, all the parameters, but in the upcoming version we will have an extended report setting, so we will be able to set the graph settings for every graph. For example, for the first control loop on acceleration, you want to show one channel, task, change the lines of the color of the lines, and all other standard graph settings. So as I'm running on the stable version now, we have regular basic report settings, but in the upcoming version, these settings will be extended.
And when will this be available?
I think it will be available in summer.
Oh, okay.
Or maybe in autumn. When it will become really stable for our users.
So it's available when it's available. Okay,
true.
Thank you. So yeah, let me check if we have any more questions now. Okay, I don't think there are many for now. There are any for now, but we'll allow, I think maybe we'll stay on for 3 to 5 minutes. So if anything occurs to you, so anything about the presentation or multi-shaker tests in general, or any tests for that matter, please type in the questions box and we're still here to answer. But of course, as always, you'll have a follow-up with maybe the webinar recap and a video if you need it. So you will have it on demand way before it appears on YouTube. So you can rewatch it, you can ask your questions. And if you're interested in like having an offer on multi-shaker tests, so you'll be able to contact us and let us know. Yeah, and on the screen you can see our contact details, so the general email for marketing is contact@RULA.tech, and the general email for support, which is really agile and they're awake pretty much 24/7 to answer your questions, is support@RULA.tech. So don't hesitate to contact them anytime you need. Yeah, thank you very much for joining. Thank you for your participation. We hope that was interesting and useful. We welcome any comment, any criticism, so don't hesitate to answer in the follow-up on anywhere. So we will be happy to improve. Yeah, thank you very much and have a great day. We're still on for 3